Good morning, everyone. My name is CH Srinath. I am from CSC department. My course title is Probability and Statistics. Today's topic about linear regression analysis. Linear regression analysis. Introduction to linear regression analysis. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables. It aims to find the best fitting line that explains the variation in the dependent variable based on the independent variables. This technique is widely used in various fields including economics, biology, and social sciences for predictive analysis. This is the introduction to linear regression. It aims to find the best fitting line that explains the variation in the dependent variable based on the independent variables. This technique is widely used in various fields including economics, biology, and social sciences for predictive analysis. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables. Next slide is the purpose of linear regression. The primary goal is to predict the value of independent variable using independent variables. It helps in understanding the strength and form of relationship between variables. Linear regression also enables hypothesis testing about the influence of predictors on the outcome. The purpose of linear regression is that the primary goal is to predict the value of a dependent variable using independent variables. It helps in understanding the strength and form of relationship between variables. Linear regression also enables hypothesis testing about the influence of predictors on the outcome. This is the purpose of linear regression. And next one is the basic assumptions of linear regression. There is a linear relationship between the independent and dependent variables. The residual errors are normally disturbed with constant variance. Observations are independent of each other and there is no perfect multicollinearity among predictors. In the basic assumptions, there is a linear relationship between the independent and dependent variables. Observations are independent of each other, and there is no perfect multicollinearity among the predictors. The errors are normally disturbed with a constant variance. These are the basic assumptions of the linear regression. And next slide is the regression equation. The simple linear regression model is expressed as y beta 0 plus beta 1 where y is the dependent variable is x is the independent variable beta 0 is the intercept and beta 1 is the slope coefficient. The error term accounts for the variability not explained by the model. The regression equation is the y beta 0 plus beta 1 x and where y is the dependent variable x is the independent variable and this is a regression equation. And next slide is the least square method. Least square method. The least squares method estimates coefficients by minimizing the sum of squared residuals. This approach finds the line that best fits the data points by reducing the total squared distance from the each point to the line. It provides the most efficient estimates under the Gauss-Markov assumptions. In this least square method, the least square method estimates coefficients by minimizing the sum of squared residuals. This approach finds the line that best fits the data points by reducing the total squared distance from each point to the line. It provides the most efficient estimates under the Gauss-Markov assumptions. This is the least square methods. And next one is the interpreting regression coefficients. Interpreting regression coefficients is nothing but the intercept beta 0 represents the predicted value of 5 when all x variables are 0. The slope beta 1 indicates the change in y for 1 unit increase in x. Significance tests determine whether the coefficients are statistically different from zero. In this interpreting regression coefficients, the intercept beta 0 represents the predicted value of y when all x variables are 0. The slope beta 1 indicates the change in y for a 1 unit increase in x. Significance tests determine whether the coefficients are statistically different from 0. This is the interpreting regression coefficients. And next slide is the model fit and evaluation. Model fit and evaluation. The R squared value measures the proportion of variance in the dependent variable explained by the model. Adjusted R squared adjusts for the number of predictors, preventing overfitting. Residual plots and diagnostic statistics help assess the adequacy of the model assumptions. Model fit and evaluation is nothing but the adjusted R squared adjusts for the number of predictors preventing overfitting. The R squared model value measures the proportion of variancy in the independent variable explained by the model. Residual plots and diagnostic statistics help assess and the adequacy of the model assumptions. These are the model fit and evaluation. And next slide is the hypothesis testing in linear regression. The null hypothesis tests whether a coefficient is equal to zero. No effect. T-tests are used to evaluate the significance of individual predictors. F-tests assess the overall significance of the regression model. In this picture, you can observe D, E, F, G, H, I, J, K, L. These are the linear regressions and summary output regression statistics, ANOVA, and coefficient standard error. In this ANOVA regression statistics, we will have multiple and R square, adjusted R square, standard error, and observations. ANOVA regression residuals total, and in coefficient standard error, intercept and hours. In this hypothesis testing is linear regression is the nothing but the null hypothesis tests whether a coefficient is equal to the zero. This is no effect. T-tests are the effect used to evaluate the significance of individual predictors. F-tests are access to overall significance of the regression model. And next one is a multicollinearity. Multicollinearity occurs when independent variables are highly correlated. It can inflate standard errors and make coefficient estimates unstable. Techniques like variance inflation factor (VIF) help detect and address multicollinearity. Multicollinearity Multicollinearity occurs when independent variables are highly correlated. It can inflate standard errors and make coefficient estimates unstable. Techniques like variance inflation factor (VIF), it is called as a short VIF, help detect and address multicollinearity. This is called as multicollinearity. And next step is the limitations of linear regression. Linear regression assumes linearity, which may not hold in complex relationships. Outliers and influential points can disproportionately affect the model. Violations of assumptions can lead to based or inefficient estimates. These are the limitations of linear regression. And next slide is the applications of linear regression. Used for forecasting sales based on advertising spend. Applied in healthcare to relate patient characteristics to health outcomes. Utilized in economics for demand analysis and price elasticity studies. These are the applications of linear regression. And next slide is the software for linear regression. Common statistical software includes R, Python, states models, SPSS, and SAS. These tools facilitate data analysis, model fitting, and diagnosis. Visualization and residual analysis are integral parts of model evaluation. And next is a summary. Linear regression is a foundational analytical tool for modeling relationship between variables. Proper understanding of assumptions, interpretation, and diagnostics is crucial for valid results. It remains a versatile method with extensive application across disciplines. And next reference introduction to the linear regression analysis. Thank you.